In this question it says a certain half reaction has a standard reduction potential of 1.32 volts. The engineer proposes using this reaction at the cathode of the galvanic cell that must provide at least 0.5 volts of electrical power. So first we want to remember the equation. E naught of the cell equals the standard reduction potential of the cathode minus the standard reduction potential at the anode. So this is basically that. But in this case, we don't have an equality. We essentially have, we're going to need to use a greater than sign. So in this case, we need the E naught reduction at the cathode minus the E naught reduction at the anode to be at least or greater than 0.50 volts. So we need this reduction potential to be at least 0.5 volts. If this said at most, then we need a less than sign. But because it's at least, we need it to be greater than 0.5 volts. Well, we know the cathode reduction potential. It's given 1.32 volts minus the reduction potential at the anode is less than 0.50 volts. Subtract 1.32 volts, subtract 1.32 volts, and we get the negative standard reduction potential at the anode is greater than 0.5 minus 1.32, which is negative 0.82 volts. Now we multiply both sides by negative 1 to get rid of the negative. Remember the sign changes, and the E naught reduction at the anode is the greater than changes to less than, because we multiplied by a negative number, is less than 0.82 volts. So it has to be less than 0.82 volts in order for this equation to be 0.5 or greater. So when we have to answer this question, is there a minimum? No, in theory it could be infinitely low. Practically there aren't any that are infinitely low, but in theory there is no minimum. How about a maximum? Yes, there is a maximum. The maximum is 0.82 volts. It has to be at least 0.82 volts in order to have a reduction potential overall of 0.5 volts. Now we need to find a reaction where that's the case on the standard table. And there are lots, but one example is Ag plus aqueous plus an electron yields Ags. And this has a standard reduction potential of 0.7996 volts, which is less than 0.82. So this will give us at least the half a volt that we need. However, we need the half reaction that's occurring at the anode. This is a reduction reaction. At the anode, oxidation is occurring. So it's not actually this reaction that's occurring. Of course, it's the reverse of this reaction. Ag solid yields Ag plus aqueous plus an electron, because oxidation occurs at the anode. So we need the reverse of the reduction reaction because we are looking at the anode. So it's very important when you read this question that you do make sure whether it's at most or at least, and whether you're given the potential for the anode or the cathode and the reaction for the anode and the cathode. One minor thing, I did forget to check this box. Yes, it's possible, and that is the answer. So that's basically how you solve this problem.